This is a hammer. I'm holding it. You, as an intelligent person watching this video, you can probably say some true stuff now. Think for a second, like, what are some true sentences you can say from the fact that Casey is holding a hammer? Casey is holding something that has mass. He could pound nails with the object that he has. This is a physical object. Casey has a tool in his hands. He's touching the hammer. All sorts of things because you understand basics about the way the world works. Welcome to Ontology Explained. I'm Casey Hart, philosopher and ontologist, and today we're going to talk more about applied inference. In the first video in this series, we talked about what inference is, which is just deriving some new conclusion or new result, new proposition from existing data or accepted information. So in this case, we have one piece of accepted information that I'm holding a hammer, and then we draw some new propositions from it, that I'm touching the hammer. And one of the virtues of ontologies and graphs is supposed to be that we can know what the meaning is of our sentences and our triples and infer new things. And we're going to see today exactly how that's possible. To do that, we're first going to show a turtle file that's got some of the core things that we need for this toy example about hammers and wood objects and material objects. And we're going to see how that manifests itself in Protege, a really popular viewer for ontologies. We're going to turn on a reasoner, and we're going to see that we can draw conclusions from even some pretty basic triples. So here we can take a look at a small ontology that I built up for this example. Nothing crazy, but I also didn't want it to just be 3 lines. It's got a little bit of depth to it. We'll do a quick summary, and then we'll get over into Protege and see how it renders there and play around with some inferences. Top level, we've got some classes, physical artifacts, physical objects, physical things, and I've related these to one another. Again, we don't need to get into too many details here, but physical things are a top level thing. They're just below owl thing, and physical objects sits below physical thing, and physical artifact also sits below physical thing. Then I've defined some stuff for some tools. We've got tool, hammer, saw, scissors, chisel, etc., wood objects and metal objects. Here I've taken both of these to be disjoint with each other, meaning that when I say something's a wood object, I mean it's primarily made out of wood, so it can't also primarily be made out of metal. Let's go see what it looks like in Protege, and then we'll see how we can add some things to do some inference. Protege, I don't know how much I've shown this on the channel. Here or there, a smattering in videos, but I'll assume maybe you haven't seen all of them. Protege is a free, if you just Google Protege Stanford, you'll find it. You can download it. If you're an ontologist and hasn't played around with Protege, you should. If you're interested in being an ontologist, you should play around some with Protege. I'm not saying the tool is perfect. There are some other alternatives out there. I mean, as I've covered before, I mostly just like to edit the turtle, but Protege is a great gateway drug into becoming an ontologist and viewing and perusing ontologies. It allows you to do some basic querying and inference, as we'll see today. And also, if you have no skills whatsoever in building an ontology, you can start out in Protege, you can click things and get a sort of WYSIWYG, create the ontology you want, then see what the output text file would be, and go back and forth between those two. That's how I taught myself, in large part, how to do OWL ontologies, because I just didn't have the turtle syntax thing down other than basic examples. I could do more complicated one here, see what it looks like in the text file, and then I'd learn it to be able to do it myself in future iterations. So what we can see in here, the class hierarchy is exactly the thing that we just saw in the turtle file. Couple of hierarchies here, but mostly let's just focus on physical thing, which is split into artifacts and objects. And artifacts, we care about tools. We've got these ones that show up underneath, and physical objects have material objects, which can be metal and wood objects. Awesome. Individuals, well, I've just listed one individual here, which is hammering nails, but now I want to create some individuals, say some stuff about them, and then see what kinds of things we can infer. I'll show us how to turn on the reasoners and do some inference. So we'll jump back over here to our turtle file, go to some example data, and now let's create my hammer, and let's just say that it's a hammer, and that's it. I'm going to save it, pop over here, it'll say the ontology has changed, let's update it, and now we've got my hammer. We know just that it's a hammer. That's all we're saying about it. And now I'm going to go ahead and turn on the reasoner. To do this, we go to the the menu for reasoner, and there's start reasoner. You have some choices for reasoners. This depends on which ones you have downloaded, but out of the box, you'll have elk and HermiT. I'm just going to go with HermiT right away. We run it, and we can look here at hammer, and we're going to notice something. See this yellow highlighted thing? It wasn't there before. If I stop the reasoner, you'll see it goes away. It also resets the view. But see, nothing's over there now. I'm going to turn the reasoner back on, start it. And we've got this right here. What's up with that? Fortunately, Protege gives us some tools to understand it. We can explain the inference. But before we explain it, I'm just going to explain it myself in English, and then we'll see how the Protege reasoning lines up with that. So we know this thing is a hammer. And if we go look at hammer, hammer is defined as equivalent to things whose primary function type is hammering nails. So given that we have a hammer, it must be such that its primary function type is hammering nails. Let's go ahead and see. We click on this question mark. My hammer is a hammer, and hammer is equivalent to this thing. And those two claims together, when we do some inference over them, generate the conclusion that my hammer has a primary function type for hammering nails. So that's going one direction here. We know that something has is a hammer, and then we can infer, therefore, that it has these other characteristics because hammer is equivalent to that. But we can also go the other direction, and we can say, like, our nail hammerer has a primary function type of hammering nails. Go over here, run it, and now we say the nail hammerer has this, but we don't know what type of thing it is. Let's synchronize our reasoner. And what do we notice? Oh, this thing is a hammer. So it goes both directions. See our explanation. This nail hammerer has a primary function type of hammering nails. That's the thing we asserted. And then we know also from the class definition of what it is to be a hammer that this is equivalent to having this primary function type. So we can prove that this nail hammer must itself be a hammer, and that's what we get out on the other side. Sweet. Here's another type of inference we can do. By the way, I'm going to highlight some basic pieces of inference here. There's actually a lot more that you can do eventually, and it depends on which reasoner you use, which reasoning profiles you use. There's a lot of technicalities we could get into, but I just want to give a smattering, a sense for the kinds of things that you can do. And hopefully this piques your interest enough to go play around with it. By the way, this is a good litmus test. If you're watching this and you feel inspired to go build your own and test how inference works, that's a good sign that you might be an ontologist or might be motivated to become an ontologist. If you see this stuff and you're just bored out of your mind, first, that probably means that I'm a bad YouTube presenter, and you should put comments in the description telling me that I can be better because I need that sort of encouragement. But second, it probably means that this is not something that really gets you going. Because as an ontologist, inference, playing around with inference, this stuff is what gets you out in bed in the morning. Now let's take a look at our object properties. We've got this tool used object property, and tool used has a domain of a situation, and it doesn't have any range here. Actually, let's go fix that. So if I go to tool used, I've got this property right here. Oh, and you can see I have that commented out, the range. And say tool used takes us from a situation, so my building a barn or something like that, to the tool used, that's got to be something that's a tool. And let's make some assertion here. Let's see, remind ourselves, what are our options? So what kind of tools do we have? Chisels. Let's make a chisel, right? So my chisel, actually, building my barn, tool used, my chisel. So now we've created a new assertion about some situation, which is building a barn, and the tool used is my chisel. Now notice I actually didn't say that this is a situation. I just gave you a sentence, right? Let's see how this plays out when we turn on the reasoner here. We're going to update it. We're going to turn on the reasoner. We're going to synchronize it. And we're going to go take a look at our individuals. We have my chisel. And what kind of thing is it? It's a tool. But again, if we look through this and we say, what are all the references to my chisel? It's only mentioned once, and it just shows up in this triple. So we haven't asserted anywhere that it's a tool. How do we know that it's a tool? We know because we have this assertion, and the tool used for my chisel has to be a tool. That's what the range of that property is. So if I want to talk about an analog here, right? If I told you, oh yeah, we've done a bunch of construction in my house right now, and we painted it Simona, or something like that. You maybe don't know what Simona is, but if I said I painted it Simona, that sounds like that thing must be a color, right? That's the kind of reasoning that we're doing here. I understand the rest of this sentence, building my barn, tool used. And because I understand the way that sentence works, I know it has to take something that's a tool in the third slot. I mean, I don't know what type of tool it is, right? We can't prove yet from this that my chisel is a chisel. All we know is that it's a tool. Excellent. Similarly, building my barn shows up, and we know that that's a situation. Also notice here, we say it's true of this situation, building my barn, that the tool used is my chisel, but it's also true that building my barn has a situation involves my chisel. Why is that? What is that inferred thing there? That just goes from this assertion. Tool used is a subproperty of situation involved. If we look at the object properties here, you'll see that situation involves is a superproperty, which just means that every more specific property entails that the more generic thing holds. Put that another way, when you have one thing that's a subproperty of something else, any statements that are true about the subproperty will also be true about the superproperty. So if I say Casey is holding this hammer, and is holding is a subproperty of is touching, then the fact that Casey is holding a hammer entails that Casey is touching a hammer. And then the last thing that I want to do here before running some queries is talk about unsatisfiable or necessarily empty classes. So let's create something that cannot be satisfied. In fact, I've already done that here, but let's highlight what I did. Let's talk about making a metallic wooden tool. I've already said that metal objects and wood objects are things that are primarily made out of those substances, and thus you can't have something that is both of those. If it's primarily made out of wood, it's more wood than anything else. It can't be primarily made out of metal, more metal than anything else, because wood and metal are distinct substances. And so I express that with this owl disjoint with wood object that says metal objects, wood objects. If you're one, you're not another, and vice versa. And now let's create some new class, or metallic wooden tool, which says that wood, metal, and tools. And of course, that can't be the case, right, as just stated. So let's see what happens with our reasoner when we run it. Our reasoner's already synced, and it's going. We can turn this asserted instead to an inferred. And we have this thing at the top called owl nothing. And these are all of the classes that nothing satisfies. Notice that we have our metallic wooden tool showing up here, and it says this is equivalent to nothing. And we can do a proof for that. Why is this nothing? Well, because this thing is equivalent to these guys, but two of them are disjoint, so nothing can satisfy them. Often you start building an ontology, and once you get really excited about owl restrictions and things like that, and you're flushing bits out, which is great, you go a little overboard, you say something that's not quite right, and you generate a contradiction somewhere such that you end up with a class that's just necessarily empty, which is almost always a mistake. We very rarely, in fact, I can't think of any cases off the top of my head. If you can, drop them below in the comments. We very rarely want to have a class that nothing can satisfy. If you're building me a math ontology and have round to square, I'm like, that's a terrible class. Don't have that. Now we can go back, look at the argument for why it's a problem, and say, okay, which of these is a bad decision? Maybe the bad decision here is like, we just don't want to create metallic wooden tool. That's not a very interesting category. Or maybe metal object and wood object, we should rethink that. Did I mean by metal and wood just has some metal in it or has some wood in it? In which case those wouldn't be disjoint, right? There are plenty of objects like this hammer that are partly metal and partly wood. I wouldn't call this a metal object. I wouldn't call it a wood object. It's a hybrid of the two, right? It's got parts that are metal or parts that are wooden. So now we've shown how we can identify contradictions maybe and some empty classes. You can do the same thing and find an ontology that's inconsistent. We won't go into that too much here, but that's the power that inference gives you. It takes your instance data, it takes your assertions that you make, and then it draws out some implications. Not necessarily every implication, and there are different tools and inference profiles we can do to expand those, but it draws out some really important ones. One that we haven't seen yet, though, that I want to end with and show the DL query tool in Protege is caching out all of the implied types that a given individual will have. So my hammer is a hammer. I've asserted that. And the inference engine is on, so you might think, shouldn't it tell me all of the types that this hammer is? If we look at the class hierarchy, look, a hammer, right, is a more specific type of tool. Tool is a more specific type of physical artifact, which is a more specific type of physical thing, which is a more specific type of owl thing. So shouldn't hammer, if we're looking at our individual hammer, shouldn't this give us all of those? There used to be a view in Protege where it would show you all of them. I spent a ridiculous amount of time trying to find that visualization. There's probably a flag somewhere I'm just missing, so I'm not able to show it to you here. If somebody knows what that is, drop it below in the comments. I'd love to know where I screwed up. But man, I read documents. I looked at some videos where people showed some stuff in Protege, but then it was past versions of it. I tried asking ChatGPT, and ChatGPT gave me terrible, inconsistent, incoherent answers as to how to fix it in Protege. It was a nightmare. Just say, I spent a long time running my head into the wall and I got nowhere on it. But here is a way that you can find these things. We can go to our query and we can say, show me all of the things that are physical objects. And it will say, here are all the subclasses and here are all the instances that we can prove. And here, notice that physical object shows down here, so we don't have anything that satisfies that. But let's say we want to claim that our hammer, let's see, our chisel here. Let's say our chisel is totally made out of metal. So it's a metal object. And we're going to save it here, and we're going to reload the ontology, and we're going to synchronize the reasoner. And now we say which things, if we execute them, are physical objects, which says building my barn is a physical object. Why is that? Because building my barn is a metal object. Oh, ha! You maybe saw that when I was typing it. I thought I was putting that under my chisel, but I put it under building my barn. That was just dumb. Good job, Protege. Thank you for catching me on that. If I say my chisel is a metal object, now, if we come back, we can upload and we can resynchronize the reasoner. Now my chisel is the thing that is a physical object. Similarly, we could go over here and look for all of the things that are tools. All three of these, my chisel, my hammer, and my nail hammer, all of those are tools. Now, to be honest with you, I use DL queries almost not at all. What you saw in this video, and for me getting ready for this video, is the most I've used DL queries in the last year. Almost all of my time is spent doing Sparkle queries, and we'll see that in some different interfaces coming up. Okay, let's summarize what we covered today. We started with me holding a hammer, realized that meant we knew a whole bunch of other things, right? We know that I'm holding a tool, for instance. What was going on there? Well, we understand things about the world, and then we draw inferences. And when we build an ontology, we are trying to model the world in a way that represents what it's like, has semantics, has understanding in it. So we expect that our ontology should be able to power inference. And we saw exactly how you can do that today using the HermiT reasoner within Protege. We made a toy example, we added a hammer and a nail hammer, and we built a barn and described what my chisel played as a role in that barn building. We ran the Protege inference engine. We looked at it in the DL query, and we saw that we got all sorts of inferences to come out the other side. We had to say this class is equivalent to this type of class. We used owl restrictions, and that gave us the semantic hooks to draw the conclusions that naturally follow from our assertions. Playing with inferences is one of my favorite things in ontology, and this kind of inspired me a little more to go back to some of my personal ontologies and some of my other work projects and add a few more hooks so I can generate some inferences there. I hope it piqued your interest. Get out there. Go. If you haven't yet, go download Protege, load a toy ontology, draw some inferences, have fun, share your experiences below. And next time, I'll see you as I show you how we can use Sparkle to generate those inferences too. It's going to be a blast. Till then.